Hello pre-calculus students. In this video, I'm going to go over some of the basics and some of the important concepts in the 2.01 quadratic functions lesson, and then I'm going to go through a few examples of the problems similar to those you'll find on your assignment. So this video should be very helpful, so I would highly recommend watching it and taking notes from it before moving on to the assignment. Quadratic equations. You probably remember from Algebra 2, a quadratic equation is an equation where the highest exponent of x is 2. So you're used to seeing it in this form here, f of x equals ax squared plus bx plus c, where a, b, and c can be filled in with any coefficient. The graph of a quadratic equation is called a parabola, and a parabola can either open up like this or down like this. It opens up if the sign of a is positive, and it opens down if the sign of a is negative. If the parabola opens up, your vertex is going to be a minimum point on that parabola. So whatever this point is, that's the lowest y value. If your parabola opens upward, your vertex is a maximum point, and that will be the highest y value on the parabola. The graph of a quadratic function. So all parabolas are symmetric with respect to a line called the axis of symmetry, or simply called the axis. So the axis of symmetry, it runs vertical and it cuts the parabola in half, and the left-hand side and the right-hand side are mirror images. The point where the axis intersects the parabola is the vertex. And we already talked about this, but if the leading coefficient is positive, the parabola will open up, giving you a minimum vertex. If the leading coefficient's negative, the parabola will open down, making your vertex a maximum. Now, we have standard form. Standard form is really nice because we can look at standard form and pick out some key information. So it's just another way to write the quadratic equation. It's still the same equation, just written in a different way. Think of it as factored form. Standard form is f of x equals a times the quantity x minus h squared plus k. This form is especially convenient for sketching the graph of a parabola because it can quickly identify the vertex of the parabola as h comma k. So when the quadratic's in this form, you can simply look at it and pick out the vertex. So the vertex is h comma k. Notice in the form it's x minus h, but the x coordinate of the vertex is h. So what that translates to is that the x coordinate of the vertex is going to be the opposite of this number. The y coordinate of the vertex is going to be the plus or minus the constant at the end. It will be the same sign as the constant on the end. So let's look at an example so you can understand what that means. Example 1. Identify the vertex of f of x equals x plus 5 squared minus 6. So the vertex is a point, so I'm going to set it up as an ordered pair. The x coordinate of the vertex, h, is going to be the opposite of positive 5, so negative 5. And the y coordinate of the vertex, k, is going to be the negative 6. So you only switch the sign for the x coordinate. So it's negative 5 comma 6. So opposite of this comma this. Example 2. Write an equation for a quadratic with the vertex of negative 3 comma 9. So we are writing any equation with this vertex, so we can be a little bit flexible. with certain values. We can be flexible with our a value. I can fill in basically whatever I want. I'll pick 6. I could have not filled in anything. It would have been 1. And then x minus h. So if the x value of the vertex is -3, I want to make sure I have +3, because remember, it's the opposite of this. Really, it would have been x minus -3, but we know minus a negative is a positive. And then k would be +9. So this quadratic here would have a vertex of -3, 9. Now here's where it gets tricky. If the quadratic is not in standard form, we can do a little bit of algebra and put it in standard form by completing the square. You may have learned how to complete the square in Algebra 2, but if not, let's review the steps. Step 1, set it equal to 0 and move the constant to the other side. Step 2, factor out any coefficients of x squared. Step 3, divide b by 2 and square it. So your b is your coefficient of x, divide it by 2 and square it. That's the number you want to add to both sides. You have to add it to both sides to keep the equation fair and balanced. Now, why do we add b over 2 squared? Because now you can express the left-hand side as a perfect square trinomial, which is exactly what we need to do to put it in standard form. So you can copy down these steps. They might be helpful when completing the square. We're going to go over some examples so you can see how to do that. First, I'm going to do a slightly easier example because I'm not going to have a coefficient of x squared. In the next slide, I'm going to do a harder example where I do have a coefficient of x squared. Okay, so step 1, set it equal to 0 and move the constant to the other side. Okay, so let's see. Set it equal to 0. And move the constant to the other side. So to move 16 to the other side, we subtract 16 from both sides. Now, I want to leave a space here. You'll see why shortly. So set it equal to 0, move the constant to the other side. Factor out any coefficients of x squared. X squared's coefficient is 1, so that step I can skip over. Divide b by 2 and square it. So this step I like to think of, take b and half it and square it. So b is 10. If I half 10, I get 5. And if I square 5, I get 25. So I'm going to half it, square it, and then I'm going to add it to both sides. Because step 4 is to take that value and add it to both sides. You have to add it to both sides to keep it fair. You can't just pick and choose one side. So I'm going to add 25 to both sides. And why do I do that? Because now the left-hand side is a perfect square trinomial. So rewrite it as a perfect square trinomial. What squared equals x squared plus 10x plus 25? Well, that's x plus 5 quantity squared. Now, I wouldn't want you to do this, but I'm just going to show you quickly why x plus 5 quantity squared gives you back this. That's because when you FOIL it out, you get x squared plus 5x plus 5x, which is 10x, plus 25. So you can see that x plus 5 quantity squared is a perfect square trinomial. It gives you back x squared plus 10x plus 25. And just for future reference, helpful hint, this number here is always the half it number, the number you get before you square it. So that might be helpful for you, knowing that information. Okay, -16 plus 25 is 9. Okay, now we're basically finished, but to get it into standard form, we just have to put everything back on one side. So subtract 9 from both sides to get it back on the left. Okay, so this is my standard form. Y equals x plus 5 quantity squared minus 9. If I were to FOIL out x plus 5, and subtract 9, I'd get the same thing as up here. It's just written in a different form. Why did I do that? Because now I can easily pick out the vertex and access the symmetry. So the vertex is going to be -5, -9. And the axis of symmetry is a vertical line. If you remember from Algebra 1, vertical lines are always x equals. And the vertical line is going to go through the vertex. So what does x equal in the vertex? -5. So the axis of symmetry is x equals -5. And it's always going to be x equals whatever that x value of the vertex is. Now, just a helpful hint. Hopefully you have a graphing calculator. Go ahead and hit y equals and type in the equation. Doesn't matter if you type in the original or the standard form equation. As long as you completed the square, right, they should be the same equation. X squared plus 10x, plus 16. And hit graph. Okay, here's the parabola, opens upward. I'm checking to see if my vertex looks like it's -5, -9, and that definitely looks like it could be the vertex. To take a closer look, I'm going to hit second graph and look at the table. Scroll down to -5, -9, and I can clearly see that that's the vertex at this point because that's the lowest y value. So I can see that that's the vertex. But if you're way off, the graph will tell you that. Like if you got 1, 3, you would know you're way off. That's incorrect. Somewhere you went wrong in your algebra, so you'd know to double check it. Okay, now we are going to do another example where we're going to complete the square. But this time we have a coefficient in front of x squared, and that's where it can get a little tricky. So first things first is set equal to 0 and move the constant to the other side. So -3x squared plus 6x, leave a space, equals +5. Now factor out the -3 from the left-hand side to make the coefficient of x squared 1. That would be -3 x squared minus 2x, leave a space, equals 5. Because that would be -3x squared plus 6x. Now I'm going to want to add whatever I need to add to make a perfect square trinomial. So to figure out what I need to add, I need to take b and half it and square it. So b is -2. Half of -2 is -1. And -1 squared is +1. A negative squared is always a positive. So I'm going to add 1 to both sides. But this is where you might make a mistake. This is where you really need to pay attention. You're not going to add 1 to both sides because you didn't really add 1 to the left-hand side. You really subtracted 3 because you have this -3 out here that's being distributed to everything in the parentheses. So instead of really adding 1, I really added -3 because -3 times 1 is -3. So to this side, I'm going to write -3 instead of +1. You only have to worry about that when you have a leading coefficient other than 1. So now leave the -3 out front, rewrite as a perfect square trinomial, which it would be x plus 1 quantity squared. Oh no, it wouldn't. It would be x minus 1 quantity squared. If you need it to double check it and FOIL it out, x minus 1 times x minus 1 would give you back this, and it's always the half it number, which is -1. So set it equal to 0 by subtracting 2 from both sides to move that back on over. Now we are done. We just have to identify our vertex and our axis. Okay, my vertex is going to be +1, -2. And my axis of symmetry is going to be x equals the x value of the vertex, which is 1. And you know what? We can take a quick look at the graph. -3x squared plus 6x minus 5, and graph it. And let's see, does the vertex look like it could be at over 1 down 2? Yes, it does. And the axis of symmetry would go right through that vertex at x equals 1. You want to look at the table. The vertex should be at 1, -2, and that looks about right. You can see that there. Okay, last example. Nope, practice problem, then last example. So try this practice problem. You can go ahead and pause the video and give it a try. I will go through the answer. You can press play when you're ready. So I'm going to quickly go through it. So you want to factor out a 2 and move the 7 to the other side. Half of 4 is 2. 2 squared is 4, so we're going to add 4. But to the other side, we're going to add 8. This would be x plus 2 quantity squared equals 1. And subtract 1 from both sides. So the vertex is -2, -1. And the axis of symmetry is x equals -2. And you could check it if you want it in the calculator. It's just to be sure. Okay, so the vertex -2, -1 looks about right, so we're good to go. Okay, for the last example, we have a projectile being thrown upward so that its distance above the ground after t seconds is given by the function h of t, h for height, so height after time t is given by the function -8t squared plus 320t. After how many seconds does the projectile take to reach its maximum height? Okay, so I have a projectile. It's being thrown upward. So when something's thrown upward, it goes up, it hits a maximum point, and what goes up must come down. So it's a parabola that opens downward. After how many seconds does it reach the maximum height? Maximum height, we're looking for the vertex. So t is my functioning as my x value here, and h is functioning as my y. So the vertex is going to be t comma h. So t is going to be the number of seconds that the projectile reaches this maximum height h. So we need to use what we know about finding the vertex to go ahead and find the vertex, and then we'll know our maximum height and how long it took. So set it equal to 0 and factor out the -8, just like we've been doing. Okay, 320 divided by -8. Whoops. Is 40. So it would be minus 40. Okay, leave a space, equals 0. There was no constant to move to the other side, that's why it's equal to 0. So -8t squared plus 320t. So now I have to add something to complete the square here. So take 40 and half it and square it. Half of 40 is 20. And 20 squared is 400. So add 400 to both sides. And let's just double check that to make sure. Okay. I'm not going to add 400 to this side. I'm instead going to subtract 400 times 8. $3,200. Okay, so that's going to be -8. And the perfect square trinomial is going to be t minus 20. It's always the half it number. -40 divided by 2 is -20. So t minus 20, quantity squared. 0 minus 3,200, but when I move it back to the left-hand side, I'm going to add 3,200 to both sides. Okay, so here's my equation. H of t equals -8 t minus 20 squared plus 3,200. So my vertex is 20, 3,200. So to answer the question, after how many seconds does the projectile take to reach the maximum height, my answer would be 20 seconds. And they didn't ask this, but if they did ask what was that maximum height, you would say 3,200 feet or whatever the units happen to be. They're not given in this problem. So that's how you would do a word problem where you're searching for a maximum or a minimum. You'd actually do the same thing. You'd complete the square and then you'd find the vertex. So if you have any questions with completing the square or if you need any help on these problems, please reach out or stop in the virtual office.